Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present about our group project. My name is Anizam Aziz bin Abu Ghafar and my fellow friend is Muhammad Nabil bin Muhammad Nur, Muhammad Haziq Nakiuddin bin Ismail, and Wan Ahmad Rahimi bin Wan Ayub. Our title for this project is Implementation and UART Link on FPGA board using Verilog. For introduction, UART or Universal Asynchronous Receiver Transmitter is one of the most used device-to-device communication protocols. By definition, UART is a hardware networking standard that employs asynchronous serial communication at a customizable speed. UART is one of the few communication technologies that simply require two wires for delivering and receiving data. When utilizing the UART module inside the microcontroller, proper frame protocol implementation is sometimes discarded. Next is UART interface. Two-way signal of each UART device are named transmitter and receiver. The primary function of each transmitter and receiver lines is to transmit and receive serial data of serial communication. A controlling data bus is linked to the transmitting UART, which transfer data in parallel. The data will be serially sent bit by bit to the receiving UART across the transmission line wire. UART with data bus. The UART interface sends data asynchronously and does not require a clock signal to synchronize the transmitter and receiver device. The transmitter creates a bit stream based on its clock signal instead of clock signal, while the receiver samples the incoming data using its internal clock signal. Both devices must use the same baud rate to achieve synchronization. Methodology. So our goal for this project is to use Verilog to create a UART link on an FPGA board. The creation of flowchart will be presented in order to provide clearer and more comprehensive explanation. This is our methodology. This is our flowchart methodology. So we can see we start and then we transmit 8 bits data from the DE2 board, and then we switch on USB UART, and then we go to Altera DE2 software, and then we start the programming. After that, we see if any error, we have to troubleshoot and we have to do the programming back. If they have no error, and then it will be the end. Next, project description. The Altera Quartus 2 software are used with an Altera DE2 1.0V Cyclone board for this project, and the application will be written in Verilog HDL. HDL design may be analyzed and synthesized using Altera Quartus 2 software. It allows programmers to arrange their design, do times analyze, examine RTL diagrams, and simulate design reaction to various stimuli and set up target device. UART data frame. There are many data fields that have been explored for this project, including start bits, data bits, and stop bits. The start bit is used as well as add data bits and two stop bits. The data field can be any length from 4 to 9 bits, and it can also be filled with parity bits. Next is baud rate generator. The FPGA development board has an inbuilt clock signal generator that generates a 100 MHz clock signal. In order to produce and deliver each bit, the UART communication mechanism requires clock signal. The serial baud rate for this project will be 115,200 bits per second in order to obtain the square-shaped pulse. The baud-tick generator module was created using Verilog HDL to get the desired output. UART transmitter. The transmitter has 3 inputs, each of which is a parallel 8 input set that hold the input data. The beginning input is used to turn on and off the transmission. Parallel data from 8 lines is time synchronized, joined together in the baud-tick rhythm, and output as a serial data stream on a single line. UART receiver. The UART receiver accepts two inputs, an input clock signal and a serial data input that contains a serial data stream sampled on a standard baud rate. After each packet arrives at the receiver, the input serial data is reconfigured into a series of 8 data lines. Next is simulation and result. For simulation and result, my friend will continue this presentation. That's all from me. Thank you.
Hello and Assalamualaikum warahmatullahi wabarakatuh and good morning to Puan Munira binti Abdul Rahman. Okay, today I'm going to do a simulation and result for our project, which is implementation a UART link of FPGA board using Verilog. Okay, before that I'm gonna tell a little bit about our project. Okay, this project is about the implementation of UART link of FPGA board by using Verilog. This project is fully conducted by using what we're using here is a quarter software version 13. Uh, oh, I'm sorry. I using for my quarters is a version 15. Okay. This development is to send some data to another FPGA development board, which also have a UART. It is conduct in bi-directional and synchronous communication between two FPGA boards. The data field can be vary from 4-bit to 9-bit. Okay, this is for our group coding here. Okay, now we're gonna before that make sure you gonna check the name for our project is correctly. Okay. Okay, now we hit run. Okay, maybe we need wait within 2 or 3 minutes here. Oh, I forgot to mention before that this coding is for UART transmitter. Okay. Okay, now our simulation is successfully finished here. Okay, without any error and 90 warning. Okay, then we want to see the RTA viewer. Just go to tools, next viewer, and okay, this is RTA viewer for UART transmitter. Okay, okay now. Okay, now we are here. When you go to new and university program, this is going to be appear. Okay, now we're gonna find a node. We're gonna find input and output. Okay, go to edit. Instead, node or bus. Go to node finder and list all the input and output here. Just press copy all, then press OK. Okay, this will appear. Okay, now I'm gonna open what I've done previously. Okay. Okay, this is what I done before. Okay, now we're gonna try hit run. Okay, this is 8-bit and we're gonna put a binary number here, which is mean this 1, 2, okay. And this is the result here. Okay, that's all for my presentation for simulation and result. Thank you. Okay, sorry for my previous video, which I did not notice that the result is not appear there. Okay, now I bet to open my previously simulation. This is a timing diagram. Okay, now we gotta uh, press run. Okay. Okay, and this is the result for timing diagram for our simulation. Okay, that's all, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil and I'm going to present about the conclusion and the recommendation of this project. So basically in conclusion, a simple application of UART on FPGA board using Verilog are developed. In this project, FPGA uses dedicated hardware for processing logic. They are not constrained by the complexities of additional overhead such as an operating system. Upon developing this project, the FPGA and Altera DE2 board were studied to have a good understanding before it can be used with Verilog. And this project is supposedly included hardware and software. This project requires to do implementation on an UART link on FPGA board using Verilog, and therefore the output will show on timing diagram and RTL in the Quartus 2 software. And during the development of this project, a lot of experience and benefit can be gained by the users. So in conclusion, yes, the objective is achieved. And for the recommendation in this project, there are recommendations that can help the system function better. Firstly, DE2 board input can be replaced with keypad. Nowadays, most people are using keypad, which is more convenient compared to the hardware, which is the DE2 board. Next, we can change the DE2 board output into the LCD display. The display is much easier because the user can see the visual indicator. And last but not least, the coding should not have any error in order to gain the accurate data. So personally, I'm sorry for the late submission. If you want to blame somebody, blame me. I take full responsibility of my team's late submission.